Okay, I guess in the previous lecture we started off on indicators, so we'll be continuing on seeing that. So let's start off with a new type of indicator, which is methyl orange. So MUH or methyl orange is a basic indicator. Okay, and MUH aqueous dissociates in acidic medium, goes in forward direction and forms Me plus aqueous and OH minus aqueous. Okay, so this in unionized or acidic form, or rather ionized or basic form, and this is in ionized or acidic form. So in unionized or basic form, this is yellow in color, and in ionized or acidic form it is red in color. Okay, so color transition range for methyl orange is in between 3.1 to 4.4. okay, so if pH of the solution is greater than or equals to 4.4, then solution is yellow, as methyl orange remains in its basic form. If pH of the solution is less than or equals to 3.1, then solution is red, and if pH of the solution exists between 3.1 to 4.4, then solution is, or rather MuOH changes color. Okay, next, based on these two indicators, let's actually see some titration and let us understand how these indicators can be useful for us in the course of the reactions. So we have a titration of strong acid with strong base. First category of titration is titration of strong acid and with strong base. So we have a burate, okay, and this burate is used for dropping standard solution of NaOH drop by drop, whose, let's say, concentration is 0.1 m, and it has been dropped into aqueous solution of HCl. Okay, so let's say the concentration of aqueous solution of HCl is 0.1 m and we are using 50 ml of the same. Okay, so we see this in time frame, that when time t equals to 0 or volume of NaOH dropped is equals to 0 ml, then pH of the solution is 1, because pH of 0.1 m HCl solution would be 1, and let's say second, we have volume of NaOH dropped as 10 ml. So now what happens, this we are going to see. So the reaction goes as follows, that we have aqueous HCl plus aqueous NaOH forming NaCl aqueous plus H2OL. So let's say initially we have millimoles of HClS Millimoles will be nothing but volume in milliliter times molarity. So millimoles initially would be 5. These are not present, and these are other we are using. Now we are dropping 10 ml, so millimoles would be 0.1 into 10 ml, which would be 1. So after the reaction, these were initial millimoles, so after the reaction it would be 4, it would have been exhausted, and NaCl aqueous formed would be 1. So H plus resultant can be written as millimoles of HCl minus millimoles of NaOH divided by total volume. So we would have something like 5 minus 1 4 divided by 50 plus 10. So millimoles H plus resultant would be 1 by 15. So this is the concentration of the H plus resultant. So pH of the solution then would be 1.16. Okay, so as the pH of the solution is 1.16, so this was initial pH of the solution was 0.1. Now pH of the solution is this was 1 rather. 0.1 was the concentration, so pH would be 1. Now pH of the solution would be 1.16. Now let's say what happens when we have volume of NaOH dropped to, means increased to 20 ml. So H plus resultant would be H plus resultant would be how much? It would be millimoles of HCl, that would remain constant, that would be 5, minus millimoles of NaOH. Now millimoles of NaOH would be 0.1 into 20, which is 2. Our total volume would be 50 plus 20. So this would be 3 upon 70. Okay. So this would come out to be pH as 1.36. Now if we have V of NaOH as 40 ml, so H plus resultant would be, what are the millimoles of HCl? Millimoles of HCl is 5. Millimoles of NaOH would be 4. Total volume 50 plus 40. This would be 1 upon 90. So pH would be now 1.95. Okay. Now if we have volume of NaOH as, let's say, 49 ml, then H plus resultant would be 5 minus 4.9 divided by 99. So that would give us 0.1 upon 99 m. So pH in this case would be now 3. Okay, now what happens, let's see, when volume of NaOH used is 49.9 ml, then H plus resultant would be 5 minus 4.99 upon 99.9. So in this case pH of the solution can be calculated, so pH came out around 4. Okay, if we have used volume of NaOH as, let's say, 49.99, then H plus resultant would be 5 minus 4.999, and volume of the solution would be 99.99. So pH of the solution would be 5, and we keep on increasing volume of NaOH very minutely. So now let's suppose we have 50 ml solution. Okay, so volume or other pH in this case would be 7. We can directly have this 7. So at equivalent point, we can say the equivalent point is reached because millimoles of HCl would be equals to millimoles of NaOH. Okay, and concentration of NaCl in this case would be 50 into 0.1 divided by 50 plus 50, that would be 0.05 m. Okay, and as the why this pH is 7, because the solution is neutral. Because in aqueous phase at this point of time it would have equal amount of H plus and OH minus ions. Now what happens when volume of NaOH is 50.1 ml? Then we can write that OH minus resultant would be equals to millimoles of NaOH, that would be 5.01, minus millimoles of HCl, that would be 5, divided by volume of solution, that would be 101.1. So we have, from this we can calculate pOH. So pOH would come around 4. Okay. Now what happens is, when we continuously try to increase the volume of NaOH further, let's say we have 51 ml NaOH, then OH minus resultant would come out to be 5.1 minus 5 divided by 101. This is 100.1 rather, because we use 50.1, so this is 100.1. Okay, so this would be 101 here, and pOH in this case would come out to be 3, and similarly pH would be 11. Okay, this is roughly 3 and 11. So we can see that when we actually had the V of NaOH from increase from 49 to 51 ml, we can see that at 49.9 total overall change in pH, delta pH would be 8, because at 49 we saw that pH was, when V of NaOH was 49, then we saw that pH was 3, and when V of NaOH was 51 we saw that it is 11, so delta pH is 8. Okay, and between 49.9 to 51.1, 49.9 pH was 4, and 51.1 here pH is equals to 10. So between 49.9 to 50.1, not 51.1, just 50.1, so between 49.9 to 50.1 pH changed from 4 to 10, so delta pH was 6. Between 49.9 to 50.1 delta pH is equals to 6. Okay, so these are the this is the level of accuracy that should be maintained when we are doing titration from burette. Okay, so how do we achieve this? So this is a real problem that we face, that in this very small amount of volume change, delta pH change is huge. So for this case, to solve this problem, we need indicators that can actually indicate us that okay, the pH range is now in acidic or in basic. So when we use methyl orange, it would indicate us that when the pH is between 3.1 to 4.4, it would change its color. Similarly, other indicators like phenolphthalein, methyl rad, and the other likes would actually indicate us that what is the current pH range, okay, at a certain point of time. So we'll be discussing more on the indicators and the use of them in the titration problems, and how do we indicate that at which point we are in the titration phase. So for these we need indicators. So we'll be discussing on the same in the next lecture. So till then, good luck and goodbye.